Welcome to the deep dive. We're here to, really dig into the complex stuff in tech and security and pull out what matters. Remember those sticky notes? Passwords just stuck on monitors. That was kind of human identity security, version zero point 0.1, right?
Yeah, the very beginning.
Mm.
Seems almost quaint now.
Totally. But now we're facing something similar, only, well, way bigger. With cloud, microservices, DevOps, everywhere. The digital world isn't just people anymore. It's dominated by non-human identities.
Uh-huh. And securing them, that's turning into a massive challenge.
It really is a fundamental shift, isn't it? We've gotten better, maybe, at managing human access, but these non-human things, they're just different.
Yeah.
Different scale, different vulnerabilities.
Exactly. We're sort of just catching up to the implications.
So that's our mission for this deep dive. We want to unpack this whole world of non-human identities, NHIs. We'll get into why these digital workhorses are such big targets now.
And the security headaches they cause, which are pretty unique.
Right. And then look at the solutions popping up, like new takes on identity and access management workload IAM, and AI too, how it's like part of the problem and part of the solution.
We'll try to tie it all together, with zero trust in DevSecOps as well.
Okay, and for this, we're drawing on a few key sources. There's an ebook, a deep dive into non-human identity security, and the Ambit Workload IAM platform. Good stuff in there.
Yeah, and also some articles covering AI agents, the NIST AI risk framework, plus best practices for DevSecOps and managing these NHIs. So pretty solid base to work from.
Definitely. Now, before we jump in, this deep dive is brought to you by our fantastic sponsors, DevSecOps at vibehack.dev, vibehack.dev, and www.cisomarketplace.com.
They're all about helping folks make smarter cybersecurity decisions. We'll mention them again later.
Okay, let's get started. Part one, this sort of invisible digital workforce, non-human identities and the risks they bring. The first thing that just jumps out is the scale. I mean, it's wild. In many companies now, non-human identities outnumber human ones by, up to 45 to 1?
Yeah, 45 to 1. That number alone. It really should make you pause. It's not just about quantity, though. It represents this huge, often kind of shadowy attack surface.
And when we say non-human identities, what exactly are we talking about? It's more than just bots, right?
Oh, absolutely. It's a whole range. You've got client workloads, think custom apps, daemons, those background processes, batch jobs, then server workloads, web APIs, SaaS APIs you connect to, databases.
And the credentials themselves, too, like API keys?
Exactly.
Yeah.
API keys, OAuth tokens, certificates, secrets, keys. All those are types of NHIs. Basically, any digital thing that needs to prove who it is to get access to something else.
So why this explosion? I mean, obviously, cloud, microservices, automation, but is there maybe something else driving it? Like, are we just building things faster than we can secure them?
That's a big part of it, definitely. The tech shifts, distributed systems, SaaS, automation. They require systems to talk to each other without a human involved. Each needs credentials. But yeah, there's often a cultural thing too. Speed is king, right? Especially early on. Get it working first, secure it later, or maybe never.
The classic move fast and break things sometimes breaks security, too.
Pretty much. And that speed, that volume, it comes with some really specific vulnerabilities.
Like the lack of intuition. A human might spot something weird, but an app won't.
Exactly. No gut feeling. If an NHI's credential gets stolen, an attacker can just automate attacks at machine speed. Things can escalate incredibly fast, much faster than a human team can react.
And the complexity, it's mind-boggling.
Yeah.
Your app talks to a SaaS, talks to a cloud service, maybe talks back to your old data center. It's this tangled web.
A hugely tangled web. And securing all those connections consistently, very, very difficult. A breach in one spot can just cascade.
Plus, these NHIs often get way too much access, don't they? Like default admin rights sometimes.
Oh, yeah. Overprivilege is a massive problem. They're often set up with broad permissions just to make sure they can do their job, without failing. But if compromised, it's like giving an attacker the keys to the kingdom.
And sometimes credentials get shared between apps or even people.
Yep. Shared credentials, hard-coded secrets in code or config files, increases the blast radius if something goes wrong.
And this isn't just theory. We've seen major breaches tied to this, like Cloudflare earlier this year.
Right, February 2024. Nation-state actors used stolen service tokens from an old Okta breach. The oversight was assuming those old tokens weren't active anymore. They were.
Ouch. And Uber back in 2022, that was a big one too.
Yeah, an attacker got past MFA, then found hard-coded admin credentials just sitting in a PowerShell script on a network share. That one set of NHI credentials gave them wide-ranging access. Shows the danger of just leaving secrets lying around.
And it's an ongoing issue, like secrets accidentally checked into GitHub happens all the time.
Constantly. Developers accidentally push keys, tokens. It's a common vector for unauthorized access. Just one slip-up.
So these examples really hit home. Given these risks, what are companies actually doing right now, and why isn't it really working that well?
Well, the usual suspects often fall short. You've got cloud IAM, right? Platform-specific identity management.
Which is fine if you're all in on one cloud, maybe.
Exactly. Good for native services in AWS, Azure, or GCP.
Mm-hmm.
But the minute you need to connect across clouds, or to a SaaS app, or back to on-prem, it gets messy. It doesn't bridge those gaps well.
Okay, what about vaults, like HashiCorp Vault?
Vaults are great for storing secrets securely. Definitely a good practice.
Yeah.
But they primarily focus on the storage part. They often assume the workload requesting the secret already has a trusted identity somehow.
Ah, so they solve part of the problem, but not the whole identity lifecycle.
Pretty much. And they still require developers to integrate their apps with the Vault APIs, which takes time and effort.
And then they're just winging it, the DIY approach.
Yeah, the manual configurations, trying to follow best practices, maybe some IP allow lists. It just doesn't scale. It's brittle, creates operational headaches, security gaps, and honestly, just burns out the security teams trying to manage it all.
Leads to that tool fatigue you mentioned, just too many point solutions, not enough coherence.
Exactly. So building this identity layer across all these different environments, managing separate identities and access rules for everything, it's just too much. We clearly need something new.
Which brings us nicely to part two, the solution, or at least a big part of it, workload identity and access management, or workload IAM, and platforms like AMBIT.
Right. It's actually a neat analogy. Think about user IAM tools like Okta, Ping Identity. They act as a trusted third party for human users, right? They check who you are, what you're allowed to access.
Okay, makes sense.
Well, workload IAM is that's basically the same idea, but built specifically for machines, for workloads. An independent broker to validate their identities and enforce access policies tailored to how they operate.
Gotcha. And navigating these kinds of complex identity challenges, finding the right tools and approaches, that's where being proactive really matters. For great resources and expert insights to help with that, you should definitely check out www.cisomarketplace.com, a really valuable site.
Absolutely.
So you mentioned MBIT. Their pitch is pretty direct. Okta for workloads. That kind of sums it up, doesn't it?
It does. They focus squarely on that workload-to-workload access problem.
Yeah.
How does your application securely talk to that database? How does your microservice securely call that API? Ambit aims to manage that trust based on verifiable identity across all those boundaries, different clouds, on-prem, SaaS.
And what are the big benefits they promise?
Well, three main things stand out. First, stopping those workload attacks we talked about, defending against credential theft, unauthorized access, key rotation issues, that service account sprawl.
Makes sense. What else?
Second, it's a big one for developers. Instead of building custom, complex authorization logic into every app, which takes a ton of time, Ambit automates a lot of that workload IAM. So devs can focus on features, not plumbing.
Saves potentially thousands of developer hours, they claim.
Yeah, that's the idea. And third, for the DevSecOps folks, it promises significant time savings, potentially 50% or more, on things like managing credential rotation, handling compliance checks, audit trails, the real operational grind.
Okay, that sounds good on paper, but how does it actually work? Let's get into the mechanics a bit.
Sure. So there are two main parts. There's the Ambit Cloud, which is their SaaS platform. That's where you define your access policies, manage identities, get visibility, logs, all that central control stuff.
But it doesn't see the actual application data, right? It's just the control plane.
Exactly. It's a control plane architecture. It makes the access decisions, but the sensitive data doesn't flow through it. Then, deployed alongside your applications, you have the Ambit Edge.
The edge, is that like an agent?
It can be. It's a transparent proxy. So if you're using Kubernetes, it deploys as a sidecar container next to your app's container. If you're on VMs, it runs as an agent. It sits right there with the application.
And that's what enables the no-code off, because it intercepts the traffic.
Precisely. The edge intercepts the outgoing requests from the workload that need authorization. It can then dynamically inject the necessary credentials without the application code needing to be changed to know about Ambit.
Okay, that's clever. And they talk about secretless off. How does that work if the workload doesn't have a secret?
Right, this is key. Instead of the workload storing a static secret, like an API key, the Ambit Edge uses the workload's environment to prove its identity. It extracts signed metadata things provided by the cloud platform or orchestrator, like AWS, IMDS, or Kubernetes Service Account Tokens. This is called attestation.
So it uses the context it's running in as proof of identity.
Exactly. It attests to its identity based on where and what it is.
The edge sends this attestation to the Ambit cloud. The cloud validates it using a trusted provider, like the cloud platform itself, checks the access policy you set up, and then gets a credential.
Where does the credential come from?
The Ambit cloud federates with credential providers. This could be the target service itself, like AWS STS to get temporary AWS credentials, or another identity provider. Or Ambit can act as the provider itself for some scenarios. It then issues a short-lived policy scope credential back to the edge.
And the edge injects that into the request.
Yep. The edge injects the short-lived credential and forwards the original request to the target service. Importantly, it also sends an access event log back to the Ambit cloud for auditing, analytics, compliance, all that.
Wow. Okay, so let me recap the flow quickly. App tries to connect. Edge intercepts. Edge grabs environment proof, attestation, sends it to cloud. Cloud verifies, checks policy, gets a short-lived credential. Cloud sends credential and policy down to Edge. Edge injects credential, sends request on. Edge logs the access. You got it. That's the core loop. And because the credentials are short-lived and injected dynamically, the workload itself never needs to store long-lived secrets.
Which must have a huge impact on managing credential rotation.
Massive. They claim up to 95% reduction in the work related to rotation because you're not constantly updating secrets within the workloads themselves. The system handles fetching fresh, short-lived ones automatically.
That's a game changer for operations and security posture. What are some typical places people use this?
Common use cases include securing access to data lakes and databases, especially in hybrid or multi-cloud setups, providing consistent workload IAM across different environments, connecting maybe legacy apps to modern cloud services.
CI/CD pipelines, too. That seems like a big area for credential risk.
Absolutely. Securing those automated build and deployment processes is crucial, making sure the CI/CD tools have temporary, scoped access, not static keys lying around.
And it ties into zero trust.
Definitely. It enables zero trust for workloads. You can create conditional access policies, like maybe this workload can only access the database if its security posture is validated by CrowdStrike or Wiz first, or maybe only during certain hours or from certain network segments. It allows much more granular, context-aware control. Okay, that makes a lot of sense. Let's zoom out now for our third part, thinking about the bigger picture: DevSecOps, AI, and zero trust. First up, DevSecOps and CI/CD. We hear DevSecOps a lot. What does it really mean in practice? How does adding the DevOps change things? It changes the whole mindset, really. DevSecOps isn't about security being a separate team or a final gate. It's about integrating security into the entire DevOps workflow. From the very beginning, design, coding, building, testing, deploying, operating, security becomes everyone's responsibility embedded in the process.
So automating security checks within the CI/CD pipeline is key.
Absolutely critical. Automating security testing, vulnerability scanning, compliance checks with every single code change. Making it part of the normal flow, not an exception.
And this is where those ideas like security as code and shift left become really important, right?
Exactly. Security as code means defining your security policies, your configurations, your compliance rules as code, stored in version control, applied automatically. It makes security repeatable, testable, auditable, and shift left is all about finding and fixing security issues as early as possible in the development cycle. Catching a vulnerability while the developer is still coding is way cheaper and faster than finding it in production.
Makes perfect sense. Are there specific tools or techniques making this easier now?
Yeah, we're seeing more tools integrated directly into developer workflows, like IDE plugins that give real-time security feedback as code is written. More emphasis on threat modeling early in design. Things like policy as code frameworks, Open Policy Agent, or OPA is a popular one, let you define and enforce policies across different tools and platforms consistently.
So really weaving security into the fabric of development. If you want to learn more about securing those pipelines and automating security effectively, devsecops.vibehack.dev is a great place to explore. Lots of good info there.
Definitely worth checking out.
Okay, now let's bring AI into this mix, especially with zero trust. Remind us the core idea of zero trust.
Simple concept, hard to implement. Never trust, always verify. Assume breach. It means you don't automatically trust anything or anyone inside or outside your network. You continuously verify identity, check device health, enforce least privilege access for every request.
So where does AI fit in? How does it strengthen that?
AI can supercharge zero trust in a few ways. One is automated threat response. If AI detects suspicious activity that violates zero-trust principles, it can trigger automated actions way faster than a human could, like isolating a compromised machine, suspending user access, kicking off an incident response workflow.
So it adds speed and automation to enforcement. What else?
Behavioral analytics is a huge one. AI is really good at learning baseline patterns. What's normal behavior for this user, this workload, this network segment? Then it can spot anomalies, someone logging in at a weird time, an application suddenly trying to access sensitive data it never touched before, weird geographic locations. It adapts to new threats much faster than static rules can.
So it moves beyond just known bad signatures to detecting suspicious behavior.
Exactly. And it can even get predictive. By analyzing all these interactions, maybe correlating weird behavior with patterns seen before actual breaches, AI might be able to anticipate incidents before they fully unfold. It's like an early warning system.
That sounds incredibly powerful, but AI isn't magic. There are ethical considerations, right? Big ones.
Huge ones. We have to be really careful. Algorithmic bias is a major concern. AI models learn from data, and if that data reflects historical biases, racial, gender, whatever, the AI will learn and potentially amplify those biases.
We've seen that with facial recognition, for example.
Yeah, the NIST study showed significant differences in error rates across demographic groups. That's why it's so important to have diverse training data, audit these algorithms regularly for fairness, ensure transparency, and always keep humans in the loop for critical decisions.
And what about privacy? AI needs tons of data, doesn't it?
It does, and that creates tension. How much data is truly necessary? How long do we keep it? Who gets access? How do we get meaningful consent? It forces us to think about privacy by design, building privacy in from the start, not bolting it on later.
Are there technologies that help with that? Like using data without exposing it?
Yes, privacy-enhancing technologies, or PTs. Things like federated learning, where the model trains on local data without the raw data leaving the device. Differential privacy, which adds noise to data to protect individuals. Homomorphic encryption, allowing computation on encrypted data. Zero-knowledge proofs. There's a lot of innovation happening there.
And explainability, too, right? Understanding why the AI made a decision.
Crucial for trust and accountability. If an AI denies access or flags something as risky, we need to understand its reasoning. Black box AI is problematic, especially in security.
This complexity is exactly why frameworks like the NIST AI Risk Management Framework, the AI RMF, are so important. What's the goal there?
Right, it's a voluntary framework from NIST designed to help organizations think through and manage the risks associated with designing, developing, deploying, and using AI systems. It's about promoting trustworthy and responsible AI.
And it has those four main parts: govern, map, measure, manage.
Yeah, it's a cycle. Govern is about setting up the right culture, policies, and accountability structures for AI risk management. AMI is about understanding the context, what the AI does, who it affects, identifying potential risks and benefits. Measure involves using tools and techniques to actually assess, test, and monitor those risks, things like accuracy, bias, security, resilience. And manage is about deciding how to respond to those identified risks, mitigate them, accept them, avoid them, and continuously improving.
And AI risks are different from just regular software risks, aren't they?
They are. Things like data quality and representativeness become even more critical. The complexity and sometimes opacity of large models introduce new failure modes, and the sheer scale of data collection can amplify privacy risks significantly. It needs its own dedicated approach to risk management.
Makes sense. Staying on top of all this, from DevSecOps practices to AI risk, is crucial. For more insights and solutions in this space, vibehack.dev is another excellent resource to keep bookmarked.
Good call.
All right, we have covered a lot of ground today, quite the deep dive. We started with non-human identities, these digital workhorses that now vastly outnumber humans in our systems, and the serious security risks they introduce because they're often overlooked and overprivileged.
Yeah, and we saw how traditional approaches like basic cloud IAM or just using vaults aren't really enough to handle the scale and complexity across modern heterogeneous environments.
Which led us to workload IAM, this newer approach, kind of like Okta, but for machines. We looked at how platforms like Ambit are using techniques like attestation and short-lived credentials to automate secure access without needing static secrets.
Reducing that operational burden and enabling things like zero trust for workloads based on real-time context.
Then we broadened out, connecting this to the importance of DevSecOps, shifting security left, security as code, automating security within the CI/CD pipeline.
And finally, we touched on AI's role, how it can boost zero trust through behavioral analytics and automated response, but also the critical need to manage its risks responsibly, thinking about bias, privacy, and using frameworks like the NIST AI RMF.
It really paints a picture of a rapidly evolving security landscape.
It does, which leads to maybe a final thought to chew on.
Go for it.
As AI agents become more autonomous, doing more complex tasks without direct human oversight, are we heading towards a future where cybersecurity is less about securing human actions and more about securing AI actions and interactions? Will the main human role become designing, training, and overseeing the AIs that manage security?
That's a fascinating question. If AI becomes the primary actor and the primary defender, how do we ensure that intelligence, the AI defender, stays aligned with our goals, our ethics, our intentions? How do we secure the AI itself?
Exactly. It opens up a whole new level of complexity and challenge.
Definitely something for all of us to think about as these technologies continue to accelerate. Okay, that brings us to the end of this deep dive. A huge thank you once again to our sponsors who made this possible: devsecops.vibehack.dev, vibehack.dev, and www.cisomarketplace.com. We really appreciate their support.
Thanks, everyone.
Thanks for tuning in to the deep dive.